more than just calculating percentages of things. Oftentimes, you have to calculate percentage changes. A quantity will increase by 50% or decrease by 30% or something like that. These percentage changes, which could either be increases or decreases, we have to learn how to deal with them, right? Let's just look at a simple example and see how it works, and then we can look at a more optimal approach to calculating it quickly. Let's say this guy was making 30,000 rupees a month last year. That was his salary, and this year he's getting a 20% hike in his salary. So then what is his new salary? That's my question. So I'm essentially asking you to increase 30,000 by 20%. Now this thing by itself doesn't have any meaning. You have to attach it to some sort of base. While it's not explicitly mentioned here, it is understood that we are talking about 20% of 30,000. So he used to have 30,000 rupees. Now he's getting a hike, and that quantity of the hike is actually 20% of the 30,000. So when you calculate that, what was the increase in his salary? The increase in salary is 20% of 30,000. We know how to calculate this. That is 0.2 into 30,000, which is 6,000. That is the increase in his salary. He was already earning a salary of 30,000, so his new salary is 30,000 plus 6,000 is equal to 36,000. Right? You have to so when your salary is increasing by 20%, you have to calculate 20% of your salary and add it back to your salary, and you'll get 36,000. Now, if I didn't tell you what his salary was and I gave you the variable s, and you have to increase it by 20%, you will say the final value is s plus 20% of s, which is s plus 0.2 s. You take the s out common, it becomes 1 plus 0.2, and that becomes 1.2 s, right? So you have to learn to do two percentages efficiently. You have to learn to quickly arrive at this scaling factor for any percentage change. So when I say a number, calculate 20% of x, you will say it is 0.2x. When I ask you what is 20% more than x, you should immediately be able to say, well, that would be 1.2 times x. 20% more than x is the same as 120 percentage of x, and this is a very crucial thing. It sounds simple. 20% more than is nothing but 120% of. Let's look at another example. I want you to increase the quantity A by 150%. That will be A plus 150% of A, which is A plus 1.5 times A, which becomes 2.5 times A. Notice that increasing by 150% is the same as increasing to 250%. Increase by 150% is the same as increase to 250%. Important. I'm not going to put it in terms of formulae which become cumbersome to by heart and remember. Let's learn these ideas using examples where you can quickly understand what's happening. Increasing by 150% is the same as increasing to 250%. So let's say, what does increasing by 100% entail? It is increasing to 200%, which basically means doubling the quantity. Makes sense, makes more sense with the examples than me saying I percent, 100 plus I percent and all that stuff. Just look at the examples and understand the pattern. Now let's look at decreases. uh, if you want to decrease the quantity B by 20%, that would be the final value would be B minus 20% of B. If you take the B out, it is 1 minus 0.2, so that's 0.8 B. Decreasing by 20% is the same as decreasing to 80%. Or a reduction uh, by 80%, let's say 20% less means the same as 80% off. These are the same things.